Hello, scientists. Thanks for tuning in. This video is about identifying the three types of variables. First, let's come up with an example of an experiment and then identify all of the variables. Experiments aim to answer questions. As a science teacher, I care about the success of my students, and success is often measured by test grades. I would love it, and I'm sure you would too, if all students earned A's on their tests. But how? I could ask the question, what can my students do to help them perform well on their tests? Let's think about it. What are some things that could help you do better on tests? Either things you know would work or things you've heard might work. What are some possible answers to our question that we could test in an experiment? I've heard that getting more sleep the night before a test will help a student get a score higher than if they slept very little. So one thing we could test is the amount of sleep a student gets before a test. I also know that studying is a big one. Usually, students who spend more time studying will do better on tests. We also tell students that the more often they attend class and come to live lessons, the better they will do on their tests. I've also heard that eating a big, healthy breakfast the morning of a test will help students do better. I also wonder about whether or not listening to music while taking a test could help. That would be very interesting to study. So here we have a strong list of things that I could test in an experiment that could help my students perform better on tests. This list of things that influence test grades and also the grades themselves have a name. These are called variables. Variables are factors or parts that can change in an experiment. If I look up the word variable in the dictionary and I look at the adjective form, the describing word, it says not consistent, able to be changed, varying. I can also use it in a sentence. What I eat for breakfast each day varies. It is variable. Some days I eat eggs, other days I eat cereal. So when we use the word variable, think back to its original definition. Variable means it is changeable or that it is not consistently the same. Then apply that to science, in that a variable is a thing that can change in an experiment. But there are actually multiple types of variables that we need to discuss. In this experiment, to determine what will help my students do well on tests, there are many variables, things that I could change. They are all listed here. But can I test all of these variables at the same time in just one experiment? No. If I allow all of these things to change at once and every student has a different combination of these factors, I won't be able to see any clear patterns in my data. I have to isolate just one thing and keep everything else the same. So at least for right now, I can only choose one of these variables to change. Let's say I am the most interested in how the amount of sleep that my students get the night before a test influences their score. This is the one thing that I'm currently interested in, and I want to study it in my experiment right now to see what will happen. This specific variable is called the independent variable. Another name for it is the manipulated variable. The independent variable is the factor or part that a scientist decides to change at the beginning or during an experiment. It is the factor whose effect is being investigated. When the scientist changes it, they want to see what the effect will be. We call it independent because its value does not depend on what happens after the experiment begins. It is independent from everything else that happens in the experiment. It is already set right at the beginning. We can also call it the manipulated variable because it is purposefully manipulated or changed in order to test the hypothesis. So when we change something at the start of an experiment, the goal is to see what will happen next. In this experiment, So far, we have identified our independent or manipulated variable as the amount of sleep students get the night before a test. In this experiment, I would have groups of students sleeping as little as 4 hours to upwards of 12 hours, either volunteering to sleep a certain amount or having them just tell me how many hours of sleep they got the night before. But why would I do this? What am I expecting to see change? Their grades on the test, of course. The whole point is to see if the amount of sleep they get affects their test grades. As on any test, we should see a wide range of grades from the group of students. So the students' grades or scores are considered a variable in this experiment. Not every student should receive the same grade, but this is a different kind of variable called the dependent variable. It can also be called the responding variable. The dependent variables are the factors or parts that are being measured, and it is what you are collecting your data on. Usually it involves making lots of observations and measurements and writing them all down. Think of it like the main results you're paying attention to. It is called the dependent variable because it can depend on what happens in the experiment. It can depend on the independent or manipulated variable. It's also called the responding variable because it responds or reacts to the variable being tested and investigated. In this experiment, the independent variable is the amount of sleep that students get before a test. And we're measuring how that influences the scores that students earn on the test. That is the data that we are collecting and analyzing. Now, what about all of those other variables we talked about earlier? We had our question related to student test results, and that's the dependent variable that we're measuring for. We had a list of all of the things that we could test to see how they impacted test scores, and we chose to just test the first one, the amount of sleep the night before. That is our independent variable. But what about these? These are still variables, things that we could change. They're different though, because we're not actually allowing them to change. These are called controlled variables. They can also simply be called controls or constants. Controlled variables include any variables that must remain the same or constant throughout an experiment. Remember, we can only change one thing at a time in order to have trustworthy results. We can only have one independent variable that we change for the experiment. Everything else must be controlled and kept constant. So in this experiment, if we are testing the influence of the amount of sleep before a test, we should try our hardest to make sure that all students have spent about the same amount of time studying, that they've attended the same live lessons, that they've all eaten breakfast or not eaten breakfast, and that they're all listening to music while testing, or all not. In addition to that, we can add a few more controlled variables too, such as the test itself. You can't give students different tests and then compare their scores. They should also all be testing in a similar or the same environment. If some students test in a quiet, distraction-free environment, they may perform better on the test than students who are in a loud, distraction-filled environment. We need to eliminate all possible factors that could skew the results away from answering our question. Now let's write a hypothesis for our experiment. This will again help us easily identify two of our variables, and you can use this as a handy strategy for the future. A hypothesis is a possible explanation for a set of observations that can be tested through an experiment. Think of it like an educated guess about what you think will happen when you perform an experiment. Hypotheses are written as if-then statements. A general hypothesis would be written like, if I change this thing in my experiment, then this other thing will change this way. I like to think of it like cause and effect. When you change something as part of an experiment to see what will happen, that's the cause. The effect is whatever you see change because of what you did. Notice how similar those descriptions sound to the variables we've been describing? That's because they are. The cause and the independent variable are the same thing, and the effect and the dependent variable are the same thing. And we can write our hypothesis by filling in our variables to the if-then statement. Remember, it needs to be an if-then statement that describes what we think will happen and contains our independent and dependent variables. A strong hypothesis for this particular experiment would be, if the amount of sleep the night before a test increases, then the scores earned on the test will increase.